Okay, so the next exam question was students in an exam were asked to write a note on nuclear magnetic resonance spectroscopy. Write a note on nuclear magnetic resonance spectroscopy. All right, so this is a machine. All right, nuclear magnetic resonance spectroscopy is a machine. All right, so you can see this is how the machine is. And this machine is all about trying to determine the structure of things. All right. So you are determining the structure of things by trying to study how the atoms of that things are arranged. All right. So now let me sound this as a warning. You see big words like this. At this stage, you mustn't actually know how they work. You simply need to what have the basic knowledge of them and know that something like this exists. Okay, so when you specialize maybe in radiology, when you specialize in radiology, that's when they'll now start teaching you at the postgraduate level how these things actually work. All right, so here we just a skinny knowledge of what the NMR actually is. All right, so for the definition, we'll go from definition, principle, instrumentation, and we go on like that. So the nuclear magnetic resonance spectroscopy is a non-destructive or analytical or technique, and is used to determine the structure, dynamics, and interaction of molecules. All right, so you have a substance and you're just trying to look at, okay, what are the molecules in this thing, what is the molecular composition, and how are these molecules interacting in this thing. All right, so the principle, the nuclear magnetic resonance actually explores for the magnetic properties of the atomic nuclei. Right, so specifically it focuses on what nuclear spin. It's looking at how these molecules are spinning in the structure. Right, so the molecules are, or the elements that this thing is actually looking at is what the hydrogen, the carbon, the nitrogen, and the phosphorus. Okay, I could see these numbers attached to each of the element symbol. Simply shows that what if it is hydrogen, this is the type of hydrogen that this thing will focus on. If it is carbon, this is a type of carbon. All right, also focuses on magnetic resonance, which is basically the interaction between the nuclear spin and the external magnetic field. How is the structure interacting with the external what magnetic field? All right, so now what is the instrumentation? It has a magnet which has a high field strength up to 21 teslas, has radio frequency core which transmits and receive what radio frequency signals. Right, so this is a radio frequency core. All right, this is a magnetic field that has about what 21 teslas. Right, then it has a console that controls the instrument and processes what data. All right, console, this is the printer. That's what will now display the information, or the basically display the answers to what you just did. All right, so looking at the types now, we have the one that could be for hydrogen, that's hydrogen NMR. We have the carbon MNR. We have the what, okay, D, that's a 2D. 2D is basically a two-dimensional what NMR. Then we have the 31P, that's a phosphorus 31 NMR. Okay, so what are the various techniques? We have the Fourier Transform, pulse frequency correlation spectroscopy, and the nuclear Overhauser effect spectroscopy. I've already sounded this as a warning. You don't need to know how these things work. You simply need to know their names and know that these things what exist in the abstract form. Okay, later on, if you get to specialize, or as you advance in your medical career, you get to know these things. All right, then moving on to the application, it helps in the structural elucidation of organic and inorganic compounds. Like, it will help you to know the structure of a compound. All right, it helps in the conformational analysis of biomolecules. Right, bio, that's molecules that are basically from humans. Right, helps in the analysis of these molecules, helps in the study of what molecular interactions and dynamics, how things interact at the molecular level. Right, helps in the what metabonomic and metabolomic analysis, right? Helps in pharmaceutical research and development, helps in food and beverages for analysis, right? So advantages is it is non-destructive. That means it does not actually make use of all those what destructive waves like the X-rays. X-rays too can be used in studying how structures are, right? So the nuclear magnetic resonance spectroscopy is another way of trying to what study how um, molecules are, all right? So it has a high sensitivity and selectivity. It can provide a detailed structural information to how a molecule is. It is non-invasive, right? So what is the limitations? It requires for specialized instrumentation and expertise. That means for you to operate an MNR machine, you must be specialized. You must be taught, okay? It has limited sensitivity for low concentration samples. That means if you want it to what? Grab how a sample is, the sample must be highly concentrated, all right? It has some interference with what? Paramagnetic substances, right? So what is a clinical application? When you advance your medical career, you always hear something, things like what? MRI scan, CT scan, X-rays, PET scans, right? So the MRI scan is made from the basis of this NMR spectroscopy, all right? Then there's another one, magnetic resonance spectroscopy, all right? And it also helps in the diagnosis of what? Metabolic disorders, because it basically gets, if it is protein now, it will study how the structure of a protein is. If it's carbohydrate, you study how the structure of carbohydrate is. And it will always help you pick up those what? Abnormalities, right? So that's it for what? Us writing a note on nuclear magnetic resonance spectroscopy.